The purpose of this video is to do a quick review over section 6.1 and 6.2, which I know we did not have quite enough time to get through both of those, and then also to do an introduction to section 6.3 on similar figures. First is a review of the vocabulary from section 6.1. It is very important to know the difference between a ratio and a rate. A ratio is a comparison of two similar quantities. An example would be comparing red apples to green apples. They are both the same thing. You're comparing apples to apples. So for example, if you did a ratio of red apples to green apples, in this lovely drawing on the left, you would say that there are 8 red apples to 6 green apples. Or you can write ratios using the word to, but the way that we most often want to work with ratios in math is writing them as a fraction. So that would be 8:6 or 8/6. And then of course, whenever you have something written like this, you would want to simplify it. So this is actually a ratio of 4:3, which means that you can actually simplify these over here as well, even though they are not written as fractions, but you can still simplify those. So that's a ratio. Next, we have a rate, and a rate is a comparison of two quantities in different units. So for example, talking about how many miles per gallon a car drives, there is no way that you could talk about miles and gallons and interchange those two things. They are two different labels. They are two different quantities. Next up is unit rate. Remember that unit rate is finding for 1. So when you are comparing these two shampoo prices, the Herbal Essence shampoo is priced for $3.79 for 12 ounces, and Pantene Pro V shampoo is priced at $4.89 for 14.5 ounces. Which is a better buy? You want to figure out how much an ounce costs. You want to know price per ounce. So since you want to know how much 1 ounce costs, you want to put ounces on the bottom, because you always want the denominator to be 1. So set the first one up as $379 for 12 ounces, and set the second one up to be $4.89 for 14.5 ounces. And then you can do the math with a calculator, most likely, to see how much 1 ounce is going to be. Well, if you're looking for 1 on the bottom, you simply just divide your numerator by your denominator. When you do the division, 3.79 or $3.79 divided by 12 ounces, you get 32 cents per ounce. And when you do $4.89 divided by 14.5 ounces, you get 34 cents per ounce. So obviously, you would rather only pay 32 cents for something than you would 34 cents. So the better buy is the 12-ounce bottle. And then we have converting rates. When converting rates, you want to remember that you can multiply anything by 1 and it technically stays the same. So think about what you want to end up with for your label, and you want to end up with inches on top. So start working to turn your yards into inches. Well, to cancel yards on the top, you need to have yards on the bottom. So you can convert yards or multiply by yard, because the equivalent of that would be 3 feet. 3 feet is exactly the same as a yard. Well, you still don't have inches, so then you want to think about, well, let's cancel feet. So put feet on the bottom, and 1 foot is the equivalent of 12 inches. And then you can cancel your feet because you've got that on the top and bottom, and you've canceled your yards. So now you've worked to get inches on the top. Now you have to work to get seconds on the bottom. You have minutes over here that you need to cancel. So let's do 1 minute over 60 seconds, because those are exactly the same amount. So that is technically the value of 1. Well, now you have your minutes canceled. So your label on the top is inches, and your label on the bottom is seconds, which is what you want. Once you've worked to get your labels correctly, then it's a matter of multiplying the numbers on the top and multiplying the numbers on the bottom. So on the bottom you have 400 times 3 times 12, and on the bottom you have 1 times 1 times 1 times 60. On the top, when you multiply 400 times 12 times 3, you get 14,400. And then, of course, you would want to simplify that. So 14,400 divided by 60 is 240. So you get 240 inches per second. When solving proportions, there are 3 ways that you can work through it. You'll probably find a favorite and stick with that most of the time, unless if you see one that's, really easy to do one way or the other. So the first way that you can solve this is by looking for equivalent fractions. One thing that I would tell you that you could look for is to see if you can simplify a fraction at all. Perhaps on this one you could divide them both by 3, and so you get 2 over 7. Now all of a sudden you have this compatible relationship here where you go, well, from 2 to 22 you multiply by 11. So if you multiply this by 11, you get D is equal to 77. So that's thinking of it as an equivalent fraction. I will show you the second way on a different problem because I don't want to confuse you with this one. So I'm going to skip right over to cross products. And when you solve a problem using cross products, you would multiply your means and extremes and set it up as an equation. So the first one, when you take 6 times, when you multiply 6 times D, you get 6D. And when you multiply 22 times 21, you get 462. And now you have a basic one-step equation. Remember, you want to isolate this variable by doing the inverse operation. So simply divide both sides by 6 to get D by itself. 462 divided by 6 is 77, which you get the same answer either method that you solve that. To check and see if 2 ratios are proportional, all you do is set it up as a proportion and then check the cross products. So this one you could check 27 is to 54 as 22 is to 44. I'm going to plug this into a calculator and do 27 times 44, and that is equivalent to 1,188. I just multiplied those. Now I am going to check 54 times 22, and that is 1,188. If those cross products are equivalent, that is a proportion. Now don't overthink this, because some of you might look at this, these 2 fractions and say, oh, I could simplify those. Well, let's see if we simplify these if we get equivalent fractions, because remember, that's what a proportion is anyway. So you can divide both of these by 9, and you would get 3, 6. You might say, I can divide those by 3 again, so I get 1/2, and then just see if the one on the other side matches. You can divide those in half. That's also, you can divide those both by 22, and that's 1/2. So 1/2 is equivalent to 1/2. So yes, those are proportional. Now moving on to section 6.3, which is on similar figures and scale drawings. Similar figures have the same shape but a different size. And you wouldn't say that it's the same shape with the same size, because then those are congruent figures. They're exactly the same. These are similar. It means that they are the same shape but different size, as I said before. And in order for something to be similar, they need to have corresponding angles that are equivalent, and the corresponding sides must be in proportion. So I have here 2 examples. The first one, they have the same shape but different size, but don't take that for granted. You have to prove it mathematically. So if you look, all 4 of their angles are the same. They are corresponding. The matching angles would be the same. They're all 90 degrees. So that makes them So those corresponding angles are equivalent. But then you would want to double check and make sure that those sides are in proportion. So if I set up that and prove it, that would mean that 10 is to 5 as 4 is to 2. And if you check that, 5 times 4 is 20, 10 times 2 is 20. So those are proportional sides. So yes, these are similar figures. If you look at the second example, the green rectangles, they have congruent corresponding angles. Those are both 90 degrees. However, if you set this up in a proportion, if you do 4 is to 6 as 10 is to 7, if you check those, you get 28 is to 60, which those are not proportional sides. And you can see that because they don't even have the same shape. They're definitely different size, but they don't have the same shape. Notice the symbol for two shapes being similar. It is this guy right here. So that statement says that triangle ABC is similar to triangle XYZ. And what that means is angle A matches up with angle X. And angle B matches up with angle Y. So order is very important on these. And then you can also see, if you look at line segment AB right here, if you look here, line segment AB should be in the exact same line segment as YX, that matching piece, and that should be in the same order in its name. These little symbols in here, this means that this first angle is congruent to this first angle, and this angle with 2 matches this angle, and therefore when it has 3, it's congruent to the matching angle on the other side with 3. And then if you look, these sides are in proportion because 6 to 9 is in proportion to 4 is to 6. Finally, you need to be able to solve for a missing side. Well, you know that similar figures have proportional sides, so you're going to use proportions to solve for a missing piece. Just to find a missing piece in a proportion, all you need to know is 3 of the 4, which you do. So if I set up this proportion, if I set it up as 3 is to 4, notice I'm starting with this one, and I'm going down to the bottom. So then on my second ratio, I would need to start with the same one on top, which is y, and then go to the bottom, which is 12. And then you just solve it. You can solve it as an equivalent fraction. That's times 3, so you could do times 3. So y is equal to 9. Or, check this out, you don't have to set up that exact same proportion. Let's say that someone else wants to be a rebel and start with 4 on the bottom and say that 4 goes with 12. Well, if you do that, 4 is to 12, then you have to start with this one on top, 3, and then put y on the bottom. Let's see if we get the same thing. There is no good relationship between 4 and 3, or I should say there is no easy relationship, but you could solve that using cross products, where 12 times 3 is 36, and 4 times y is 4y. Divide both sides by 4, and you get a side length of 9, which is exactly what you had solved setting it up the other way. You just need to be consistent with your placement, either vertically or horizontally. Matching pieces either need to be lined up vertically or horizontally. Scale drawings. There are certain things that you have to keep the integrity of the original form. Like you can't shrink it or stretch it too much because it'll compromise the original format. Photographs are one of those. You can't take a 4x6 photograph and just shrink it down to 1 inch wide and keep the same width because it would squish everybody in it. So you have to keep the enlargement consistent or proportional. So on this one, again, scale drawings, it's all set up using proportions. So if your original photograph was 4 inches wide and 6 inches long, you may want to be specific in your labeling so that you set it up correctly and you match it. So the original photograph was 4 inches wide and 6 inches long. That helps you with setting up the labels on the other one. So the question is, a photograph is enlarged for display at the art gallery. The photo was originally 4 inches wide with a length of 6 inches. If the enlarged display is 5 feet wide, that should say, how long is a display? So now all of a sudden you're talking about your width being 5 feet. Well, since I'm talking about the width right here, you have to talk about the width on the top on the other one. So this is 5 feet wide. So I know that I'm talking about my width on the top, but notice that I went from inches to feet. That's okay. If you're talking about feet over here, you'll know that it's feet on the bottom here because you had inches and inches on that one. So to solve this, that looks really yucky with all of the circles and the letters. So if I just wrote this as a basic proportion, it would look like this. And maybe I want to call that L for length. Well, to solve it, use cross products because there's no easy relationship. So that's equal to 30 is equal to 4L. Divide by 4. And 4 goes into 37.5 times. So the length would have to be 7.5 feet. And you know that label because it had to match. So the length of that display at the art gallery would be 7.5 feet. Again, just use proportions and be consistent with when you set them up.